Okay, so we are going to go and prove the exterior angle theorem. So again, the measure of an exterior angle is equal to the sum of the two remote interior angles. So if we know, for example, let's say this is 50 and this is 60, then we know this has to be 110 degrees, just as an example. So let's go ahead and prove it. So we are given that we have a triangle ABC, and there's a ray AD that is extending from that one side. So we're supposed to refer to the picture above. So we'll look at this diagram. Okay. And what we want to do is we want to prove measure of angle CBD is equal to the measure of angle A plus the measure of angle C. So let's start out with the measure of angle ABC plus the measure of angle A plus the measure of angle C is equal to 180 degrees. This is the triangle sum theorem. That's what we had just learned previously in this section. So the fact that the three interior angles of a triangle add up to 180. Now if we look closely, we see here we have a linear pair. So I know, actually before we say that, we're going to say angle DBC and angle ABC are supplementary. This is the supplement theorem, or linear pair implies supplementary angles. So if they're supplementary, then I know measure of angle DBC plus the measure of angle ABC has to equal 180. So that's going to be definition of supplementary angles. Now I'm going to do some substitution. So I see that from statement 2 and statement 4, these three angles add up to 180 and these two angles add up to 180. So I'm going to combine those and say measure of angle ABC plus measure of angle A plus measure of angle C plus measure of angle DBC plus measure of, or sorry, that's supposed to be equals. So equals measure of angle DBC plus measure of angle ABC. This is substitution, or you could use transitive, but since it's equals, I'll use substitution. Now, what do we notice that we have on both sides? We have the measure of angle ABC. So if I subtract that from both sides, I will get measure of angle plus measure of angle C equals measure of angle DBC. That's subtraction property of equality. And so therefore, I know that things are kind of switched around a little bit, but basically using symmetric property, I could switch that around, but it's fine. Measure of angle CBD equals measure of angle A plus measure of angle C. Okay. Okay, looking at example 4, we want to find the measures of angle 1 through 5. And we have a number of different triangles here. Now, we don't necessarily have to go in order. So, for example, I can find angle 1 first. I could see angle 4 and 120 degrees, form a linear pair, a number of different ways. But let's start with angle 1 anyway, because we can see 50 and 78 are remote interior angles to this angle 1. So I know measure of angle 1 has to be equal to 50 plus 78. So when we add those, we get 128. Then I can see angle 1 and angle 2 form a linear pair. So I can subtract 128 from 180, and we get 52. If 120 degrees is here, I know this has to be 60, and then I can see 52 plus 60 plus measure of angle 3 equals 180. So we get 68 for angle 3. Measure of angle 4 also has to be 60. Those form a linear pair. And then angle 5. So I see 5 is a remote interior to those two. So I know angle 5 has to be 60 plus 56. Again, this is not the only way to get to those solution. Just one way, one path to get there. So there's 116. Okay, here's another picture. We want to find the measures of angles 1, 2, and 3. I see angle 1 is an exterior angle to these two. So measure of angle 1 is going to be 32 plus 23, which equals 55. Okay, and then I can see if angle 1 is 55, then it forms a linear pair with this angle that's 125. So I can see measure of angle 3 is a remote exterior angle to 125 and 22, so that gives us 147 for angle 3. And then I could see 2 and 3 add up to 180 because they form a linear pair, so I get 33 degrees. Next, definition of a corollary. So a corollary is something following a theorem. So this is something that can be easily proven. So again, it's still something that we usually prove following a theorem, but generally in this class we're just going to give in the corollary, and it usually makes sense because for example, this corollary 4.1, the acute angles of a right triangle are what? Well, if measure of angle G plus measure of angle J plus measure of angle H have to be equal to 180, and we see that H is 90 degrees, then that means if I subtracted 90 from both sides, I know G and angle J have to add up to 90. So regardless, anytime you have a right triangle, the acute angles are going to be complementary. That's a corollary that follows the triangle angle sum theorem. And then there can be at most, and this is something we talked about in the last section, one right or obtuse angle in a triangle. We can't have more than one obtuse. It wouldn't create, right? If we had two obtuse, there's no way those would join. Same thing if you had two right angles. So you can't make a triangle in either of those cases. Okay, example 6, find each measure in triangle DEF. So I see here's a right angle. So if I'm just looking at this triangle DEG, I can see measure of angle 1 plus 25. That has to be, those two angles have to be complementary because I can see it's a right triangle. So that means if I solve, I get measure of angle 1 equals 65 degrees. And then same thing for the other one. So I can look at this little triangle here. This is a right angle, this is a right angle. So I can see measure of angle 2 plus 65 equals 90. So it makes sense that angle 2 is 25. Okay, I think you should be good to go for the homework assignment. Try to get as much as you can done so that we can go over the homework problems next class.